Hey everybody, this is Mr. Longo, and in this video we are going to cover arithmetic sequences. So you have two formulas that you need to know. This one right here, this is the one you're going to use the most. It's a sub n is equal to the first term, a sub 1. Sometimes it's just the letter a without the 1. It's fine. Plus d times n minus 1. You also have a recursive formula, which just means the previous term plus the difference. Your common difference. The only exception is you must state what the first term is so we know what to compare to. Okay, so for a majority of these questions, we're going to use that first formula. For example number 1, it says 3, 7, 11, 15, find a sub n. That just means write a formula for a sub n. So that means a sub n is equal to the first term, which we know is 3, plus d, which means our common difference. If we look at this, we're going to go up 4 each time, so our common difference is 4 times n minus 1. And then the rule just means we just have to distribute our 4. So a sub n is equal to 3 plus 4n minus 4. And that means a sub n is equal to 4n minus 1, and that is our rule for a sub n. Next example. We are given a, which again, as I mentioned, could be a sub 1, and our d, we're going to find a sub 9. So that means a sub 9 is equal to the first term, 5, plus our difference of 3 times n minus 1. Well, remember, this is n, so that's 9 minus 1. So a sub 9 is equal to 5 plus 3 times 8 is 24. So a sub 9 is equal to 29, and you are done. So really it all depends on what you are given and what you are trying to find. So sometimes the examples are very simple. Number 3 is not bad at all. You just have to pretty much find a sub 12. So very similar to the last example. It's just you're given some numbers, so you have to find your own common difference. Number 4 is a multi-step though. But I'm going to ask you to pause the video and try these examples on your own and see if you can handle them. They're not bad. Like I said, tip number 4 is multi-stepped. Give it a shot. Okay. So, a sub 12 is equal to your first term, which is a negative 5, plus your difference, but this difference is going down by 2, so it's minus 2 times 11, which would be your 12 minus 1. So then you're going to have a sub 12 is equal to a negative 5 minus 22. So a sub 12 is equal to a negative 27. If you got that, you are good to go on that example. The reason why number 4 is multi-stepped is because we know that a sub 19 is a negative 45. But we don't have our first term. So we need to find a sub 1. We are given that d is a negative 3 times the number of terms. That would be 19 minus 1. Is 18. So once you do that, you get your negative 45 is equal to a minus 18 times the negative 3, 54. Add 54 to both sides, and we know that a is equal to 9, or a sub 1 is equal to 9. Now that you have a sub 1, we can go find a sub 2. So a sub 2 is equal to our first term, 9. We know our difference is a negative 3 times 2 minus 1, which we know, of course, is 1. So 9 minus 3 is 6. So a sub 2 is equal to 6. Okay, so that is an example of one where that you will need more than one step. Okay, number 5. This one is just writing a recursive formula. So remember, recursive formula, it is absolutely crucial that you state your first term, but then you're just comparing to the previous term. So to get from negative 3 to 1, we add 4. From 1 to 5, we add 4. So we know that our difference is going to be adding 4 to the previous term. So we need to say a sub 1 is equal to a negative 3. And then we know that a sub n is equal to the previous term, which we write as a sub n minus 1 plus 4. Okay? It really is that simple. But you just, writing a recursive formula is a little bit different than just finding a sub n, because you must compare to the previous term and you must have the first term. Okay, last example here. This one is just a lot of algebra. So when you have 3 terms of a sequence, remember, the difference is always coming from subtracting. So let's just pretend that this was our first term, second term, and third term. If we wanted to find the difference, we would always subtract the second term and the first term. And we would subtract the third term and the second term to find our difference. So, in order to solve a question like this, what you need to do is say the second term, 7x minus 32, minus the first term, 3x minus 3, is equal to the third term minus the second term. Because if the common difference is going to be the same, you're going to subtract the bigger one from the smaller one in terms of the number in the sequence. And then all you're going to do is a bunch of distributing, combining like terms, and then plugging things back in. So we're just going to have our 7x minus 32 minus 3x plus 3 is equal to 2x plus 11 minus 7x plus 32. Okay, combine our like terms. 4x minus 29 is equal to a negative 5x plus 43. That's going to give us 9x is equal to 72. So x is equal to 8. Now, all you have to do is substitute 8 back into your 3 terms. So 3 times 8 minus 3 is going to give us a 21. And 7 times 8 minus a 32 is going to give us 24. And 2 times 8 plus 11 is going to give us 27. Okay, and that's how we find the 3 terms of an arithmetic sequence when they are all expressions. And that's how you solve. All right, that's it for this video. This is Longo, and I'm out. See you, bye.